so much delay because there are some technical glitches. So I'll quickly start and come to the point. And basically, I'll give you some overview of the satellite sensors that we use for atmospheric and oceanic hazards. And first, I start what are those hazards and actually that we are looking for. So as you know that today the weather prediction basically or ocean predictions are used for many applications, and nowadays this science has matured to a high level where they can be used and they can be relied, and they can be utilized for several applications like agriculture. Even when you go for a cricket match, the weather plays a very important role in that. So even how much and a lot of sea state, even a lot of commodities in the market, a lot depends upon that. For example, whether or not the summer will start from the next week, so people will start gathering commodities accordingly. So that is one thing. And then suppose there is an extreme heat waves, and then the demand of certain things increase and demand of some other things decreases. So that all actually a lot of business and a lot of things actually depend upon the weather, and that is why it's very important to predict the weather. And then you know that there are so many other things like aviation, and aviation depends a lot upon the weather forecasting. Similarly, the frost, etc., fruit agriculture, tropical cyclones, hazards, storms, all these things, I mean, in a large number of areas are getting affected by the weather. And particularly now there is one more element to that, that's called the climate change, and it is affecting a lot of decisions worldwide to how the people think and how the people work and how people do business. It is the climate change has a lot of impact of that. Similarly, the applications of satellite-based weather forecasting is that I can tell you, because since this lecture is about the hazards, so let me just focus on the hazards. So there are tropical cyclone is a big hazard actually. When tropical cyclone strikes, then there is a big problem for people to relocate the residents and shift them to the safer places, and it involves a huge amount of the civil and transport operations, and all the administrative things are to be taken care. And there is it is a huge operation actually to evacuate and settle the people to a different areas. You have to manage food for, I think, millions of people who are affected by those hurricanes, so cyclones or hurricanes. So that is one thing. Another thing is actually the heat waves. Actually, the heat waves are becoming very prominent nowadays, and they are increasing. Actually, there is a trend. There is a study that the heat waves are increasing. So every year, there are chances of getting heat waves are more. Similarly, then we have floods, we have tsunamis, we have so many like other hazards like which are related to weather and oceans. So basically, these all hazards, what is these all hazards? We call them the hydrometeorological hazards. So basically, they are related to hydro means basically water. So most of the hazards are related to water, because water is very important. But when water is out of control, what happens that it plays havoc. For example, it plays havoc when it floods, when it droughts. If there is too much of the water or too less of the water, it is a big problem. And then like the tropical cyclones are also creating a hazard because of the rain. And rain is basically the problem that affects the transportation. You cannot reach the people for evacuate or helping them. So this becomes a problem. So basically, there is a big cost of the natural hazards. And this is a simple table that how much floods each hazard has caused. So this is a very big exposure or very big economic cost to these hazards actually. And that is why we have to understand, we have to predict them, or we have to first observe these things very correctly. And these are the natural disasters by number of the events. So you can see that the total number of events, the first number is the floods, then second thing is the storms, which includes the tropical hurricanes also, or cyclones also. Then earthquake, of course, earthquake is not a hazard that is covered under the meteorology or the atmospheric science. It is a geophysical hazard. Then extreme temperature, that is definitely a hazard that is related to the weather and climate. Then landslides is partly related to the weather-related hazard because it is initiated by the rainfall. and drought, wildlife, volcanic activities. So this is the number of occurrences of these number of occurrences on a yearly basis. And due to some reason, this hydrological, meteorological, and climatological hazards are increasing. There is basically there is an increase in these hazards. Actually, they are increasing year after another. So you can understand that the climatological hazards are increasing because there is a lot of variability in the weather. So earlier these patterns were following a seasonal distribution. For example, that when the rain is coming, when the winter has to come. But nowadays, these are becoming more extremes. So their extremities are increasing. So sometimes if it is cold, it is extremely cold. It is raining, it is extremely raining. It's highly, it rains like it is like a catastrophic rain. Or maybe if it is summertime, then the heat waves are becoming unmanageable. So the magnitude of these scales, amplitude of these calamities or these hazards are increasing. So this is a study, and if you weight it by the exposure, because there is more population, there is more properties which are exposed to these kind of hazards. So if you consider that factor, then it becomes a really this scale actually becomes even more. So these things are very important considerations for nowadays. In our times, what are the hazards? That the tropical cyclones are increasing. As you know that in Indian Ocean, earlier there were very few hurricanes or cyclones are coming, but nowadays you can see that every year there is one cyclone, one powerful cyclone, very big cyclone visits Indian coast every year nowadays. And sometimes, like in 2019, I think there were 8 tropical cyclones, out of which 6 reached very severe intensity. And that was quite rare. So there were the hurricanes, the cyclones were keep on coming in that time. And that kind of things are becoming very scary. And then this phenomena can be expected to repeat in the future. And these damages of by the hurricanes, actually this is proportional to the cube of the wind speed. So if the wind speed increases by 2 times, the destructive power of those winds increase by 8 times, because it is approximately the cube, to the proportional to the cube of that. So so it means it's not that if it is from 40 to 80, then it is just twice. It's not twice. It is 8 times. So that is the problem, and so that is why we have to understand. And these things are increasing. There is a study by that. So that every next year you will find a very powerful hurricane or powerful cyclone hitting your land, but there is a limit. It will saturate at some point, and after that they will stop increasing. So, but there is still a scope that when the cyclones can become even more powerful for next maybe 50 or 100 years. So that is one thing that we have to clearly understand, and we have to make observations for that. Then there is a extreme rainfall. That this is the graph, and how these extreme rainfall events have increased year over year. This graph is slightly old, so it is only up to 2019. I don't have the data for beyond that, but it is certainly it is on the rise. So extreme rainfall, you can see that in the month of summer, monsoon time, you hear the news of one flood after another flood, and these keep on increasing. Actually, this is a constant increase in the last 10 years. Heat wave is another phenomenon. Actually, sometimes there are some times which are when all India and a lot of parts of India and Pakistan regions, they are under extreme heat conditions, and the people who are less resourceful and who are of the old age, they are very much susceptible, and they are more basically they are more vulnerable to this kind of problems, because in their lifetime they had not experienced. And some people who are already ill, for them the scorching heat can become a extremely big problem, because they cannot cope up with this new problem. And this is all related to the weather related phenomena. So what it is then it is important to see, observe these things, and then understand that why these phenomena are increasing, what is the reason, and how they are increasing. And then you can see this graph, they are constantly increasing. This blue graph is just a heat wave events, and then this orange graph is basically when you weight them by the exposure. Means exposure means how many people are being affected by that. So and how much damage is there to be encountered by this kind of events. So this exposure is increasing year after year. So that's how this is increasing. Then air quality is one issue. You can see that during the month of November, October, November, there is a big problem in the when there is a stubble burning, and there is this it actually affects the entire air quality of Punjab, Haryana, and Delhi, etc. And this is one big health problem at that time actually. Then similar to the atmospheric hazard, there are oceanic hazards also. So what are the oceanic hazards? Like there are some hazards are slow hazards, some hazards are very fast, rapid hazards where rapid action has to be required. So for example, the slow hazards are sea level rise. So even though sea level rise is not happening at a very fast speed, it is happening at few millimeters per year. But ultimately its impact will be seen sooner or later. And some of the cities will be completely underwater. Some of the cities will be getting submerged, and it will increase the impact of tides and other high floods and the storm surges, and that is one problem. One is the rapid response hazards are like rip current. So sometimes the rip current, sometimes because of the bathymetry, sometimes because of the soil deposition or the sand deposition, some situations are created in the waves which creates a wave to go means into the sea. Normally the waves come from sea to the coast, but there is certain locations on the sea where it is very dangerous because these form a wave structure which goes into the sea. So whoever is going there, even though he is a very good swimmer, he can be washed away into the sea, and the waves will take him very, very far into the sea, and then it becomes very difficult to get recovered from that unless you get some help, timely help. So that is why some zones has to be identified where the rip current danger is there. So some people have identified, but these keep on changing. So one rip current zone remains active for maybe 2-3 years, and after that one new zone forms where it becomes very dangerous. So until and unless you monitor them very carefully every year, and you can find out that where the new rip current zones are being formed. So this becomes very difficult. Otherwise, somebody will wash away, and then people will say, "Oh, this is a new rip current zone." So this is like that because it is formed by the deposition of the sands and creation of the bathymetrical structures, so that some of the beaches become very, very dangerous for swimming. Similarly, there is a tsunami which is created by the earthquakes. You all know about that. So this is a very, very rapid response disaster. Then another not so rapid, but it is not so slow also. So this kind of things can happen over the period of years. That's called the hypoxia. And hypoxia is a state of the atmosphere, state of the sea when sea becomes like a dead. And actually, this happens near big cities. Actually, what happens that the big cities dump a lot of pollution, a lot of nutrients. We dump a lot of food and food waste, etc. Actually, it is a nutrient. It is like a fertilizer for water. So a lot of creatures actually they get benefited by this fertilizer what you throw into the water. But what happens that if it is excess, if it is more than necessary, then what happens that it depletes a lot of oxygen from the water, and ultimately it becomes a dead zone. So a lot of the fishes cannot survive in that kind of water, and this becomes economically highly economically hazardous because you lose a lot of business because of kind of fishing. So the similar kind of things are happening near our big cities like Kolkata and all these things, and where this kind of dead zones might be created. So we have to know and understand and monitor this kind of dead zones, what is happening over there, so that we can protect this kind of things from happening, or we can make some policy decisions about that. Another big hazard is the oil or gas spills. So sometimes they are natural. Most of the time they're natural. So what happens that there is a big there is some leakage from the mountains or some rocks inside the sea, and then there is a lot of spillage of the water or oil. So it has to be, a lot of marine life, marine fishes, they get affected by that. There is they completely choke the oxygen. They make them cripple. and they affect their ability to survive. So this is a very big thing, and it has to be detected, and some solutions to be found out that how it can be done. And most of the time, it is done by the oil tanker leakage also. Sometimes two ships collide, there is some accident by the ship, and then there is a lot of spillage of the oil and gas on the water, which is very, very dangerous for the marine life. Another thing is the harmful algal blooms. Most of the time, these harmful algal blooms take place inside the lakes, but they also happen in the oceans also, and they sometimes they want some kind of algae. So most of these algae are very good for the fishing, and they support a lot of life forms, but not sometimes it becomes in excess, and they create a kind that is called the cyanobacteria. They create some kind of cyanides, which is very poisonous. So they make the fishes very toxic, and it creates a lot of health issues. For example, if somebody consumes that water, of course nobody consumes ocean water, but if it is in the lakes, so if somebody consumes that lake water, like a lot of animals consume lake water, they create a lot of health problems, like big health issues, and even deaths are reported because of the harmful algal blooms. So these are the oceanic hazards, and how we have detected that. These are the other things like acidification and slowing down of the ocean conveyor belt, and ocean plastic, the microplastics. These are some of the other hazards. This has to be monitored. And the ocean is such a vast scale, it's such a vast area, it is very difficult to monitor them by ship or by boats. It is nearly impossible to monitor all these hazards by ships or by some other means, or by aircrafts or by drones. It is such a vast scale that you cannot imagine that how vast it is. It is very big, and you require only satellites to do that. So satellite has that kind of capabilities, that kind of scales, and that kind of coverage, that it can monitor these things very carefully. That is why satellite sensors are extremely important in today's time to monitor what is happening at the global scale, at the not in the land but over the ocean also. So for everything there is three processes. First you observe that phenomena, then based on the observation you try to understand that phenomena, and then based on your understanding, make some process, make some models, and you predict it. There are models people have made, even the climate models, where they can give some direction that where these things are going, where after 100 years, how many hurricanes will be forming, or how much the temperature will increase, and how much rainfall will happen, how much pollution, of course, is pollution, or maybe what will happen to marine life, what will happen to marine systems. So all those things you can predict once you know about the process of those things that are happening over there. So these conventional observations are very important, like a lot of weather observations like wind, temperature, pressure, humidity, rainfall, solar radiation. It is actually measured by the ground-based instruments like the one you are seeing here. But they cover a very small region, and the ground base, they take the observation over the ground only, not over the upper atmosphere. So you can see that this is the picture of how many ground-based stations we have. So approximately they have 10,000 supported by the government, but I think there are more than 250,000 which are by the private companies. A lot of private people, they install something on their properties. There are a lot of businesses, as I told you, who need to monitor the observations, and they are not satisfied with the so less number of observations. So they have installed their own. So it is 250,000. It was the situation in 2020, but now probably it must be maybe 500,000. But that despite that, there is a lot of area on the Earth which is not covered by these observations. You can see almost most of the area on the Earth is blank. And ocean, of course, ocean or the ocean regions, it is almost zero. So it is very difficult to maintain a weather station over the ocean. You have to go there, you have to install it, and it becomes very, very difficult task. So that is the problem. And the thing is that The atmosphere is three-dimensional. So atmosphere is not confined just to the surface. You need to understand what is happening at the upper level, what is happening at 2 kilometers, what is happening at 3 kilometers, 4 kilometers, 5 kilometers, etc. So to understand how the weather will how the weather is behaving. So you have to really look what is happening at 5 kilometers above the surface. So who can give you this kind of observation? Only aircraft can give you this kind of observations, or satellites can give you this kind of observation. Upper air observations are also like that. There is a our traditional balloon. People launch a balloon. That is still the very highly reliable. Even in today's time, balloon launching and one instrument it is attached to the balloon. This gives you the most accurate observations of the atmosphere. So even in the satellite time, this traditional method is one of the very, very important source of observations for the upper air. But we are trying to replace this thing by satellites, but still there is no match for these observations actually. But these observations are very, very few. This is the upper air observation network. Again, and it is very costly to maintain a balloon network. Somebody has to go there, fill the balloon. It is very dangerous because you have to deal with hydrogen gas. This is highly inflammable and extremely dangerous gas. And you have to maintain, it's very, very costly affair. And that is why in the whole world, there are only 1,000 such operations. Private companies don't have this kind of, most of private people don't have this kind of facilities to launch a weather balloon every day or twice a day. So this is expensive. So that is why we need satellite. This is the aircraft observations, and you can see that in the time of COVID, when a lot of flights were not there, there is a lot of drastic reduction in these two, in the flight data that you are getting. So this is the first is before COVID, and this is during COVID. So that is you have to depend on the flights. If the flights are not happening, this data will be affected. So we have to depend upon some source, which is this is the ocean observations also. We need some source which can give us continuous observation without COVID or with COVID, etc. So we need something reliable, round-the-clock observations. So that is the only one source that comes to our mind is basically the satellite. So satellite give you the round-the-clock observations of that. And what is the advantage of that? Those satellite observations, that there is no doubt, but the thing is that they have a big coverage. There's a huge coverage. They have a repeativity. They come repeatedly. They give you repeated observations. Once you launch a satellite, it serves you for several years, and they are the representative observations. Representative observations means it is the same instrument that is making the observation throughout the world. Not like the ground-based instrument. For example, I have an instrument, and you have an instrument. So I don't know what your instrument is measuring. And it is like a clock. For example, I have a watch. You also have a watch. We have the watch by the same company, but I am not sure what is the time in your watch and what is the time in my watch, because they are calibrated differently. They are two different instruments. But in satellite, this is not the thing. Satellite is the same thing which is measuring. So if we know that there is something wrong with these observations, we can correct those things, and it's corrected everywhere. So that is the big advantage of that. So this is the history of those things. I don't want to go to that because the time is short. So there is a lot of development in this the satellite observations since 1960s, when it was just a analog picture. Analog picture means basically the black and white picture which you used to see in the 30-40 year back when the things were not digital. So that time, what kind of picture we are seeing? So that is the picture that I'm talking about. And since that time, the thing has moved a lot. And now people are going to hyperspectral. There are thousands of channels in. Tens of thousands of channels in one satellite. There are profiling of people are doing for the wind profiles. They are taking measurement from all sorts of things. There are new innovations are going on in the satellite technology. So people are applying their mind and applying their intelligence to provide not only the satellite observations, but they are using a lot of other tools like artificial intelligence to extract a lot of information from these satellite measurements. So a lot of big things are happening in satellite things. So this is one satellite that is called the geostationary orbit. Actually, the advantage is that with the geostationary, it moves with the same angular speed, not speed, but same angular speed. It maintains the same angle as the Earth. So what happens that it looks the Earth as if it is stationary. So Earth looks stationary for it, even though the Earth is moving, but it also moves with the same angular speed. So what is the advantage of these things? You can monitor one weather like the cloud movement constantly with this. So this is the very useful platform for operational weather hazards. Like anyway, this forget about that. Yeah. So a lot of useful things are there, which I'll just come to you later on, a little moment later. And this is another thing is polar orbit. So yeah. Sorry. This is the slide. So what is the advantage? What is the advantage that you can constantly monitor? For example, I want to monitor India, so I can monitor constantly without bothering about whether the Earth is rotating or not. So I am constantly focusing on one part. But the problem is that it is giving me one satellite will give me the observation of India only. So I don't know what is happening in China or in Pakistan or in Africa, etc. with one satellite. So one satellite will give me just one point of view. That's all. The advantage and actually this geostationary satellite orbit is at 36,000 kilometers. So it is very far from the Earth actually. 36,000 kilometers means you get very poor quality images. You don't get very sharp images like when you are very near to the Earth. So that is one disadvantage of the geostationary satellite orbit. The big advantage of the polar satellite orbit is that you can place the polar orbit very near to the satellite, very near to the Earth. You can place a polar satellite at 800 kilometers or maybe 500 kilometers from the Earth. So 36,000 kilometers versus 500 kilometers, it is a big difference. So polar satellites will give you very sharp images of the Earth. They will give you meter resolution, or maybe in the Earth, where in the geostationary you get 1 kilometer resolution. So that is the big problem. So but the thing is that it will cover only one strip of the Earth at a time, and then it will move to the other part of the world, and it comes to the next time after 12 hours or maybe 9 hours or maybe 8 hours or something like that. So it will not, you cannot monitor one place continuously with a polar satellite. So suppose there is some disaster has happened just now, so you have to wait for that satellite to come to that place. That is the disadvantage. And advantage is that they give you very sharp images. So basically, this weather and ocean satellites operate on the three main frequencies. Ultraviolet, electromagnetic radiation covers a very large range, starting from gamma rays to ultraviolet, visible, infrared, microwave, radio, long, and then the longer wavelength. But this is the range of the satellite sensors they don't work mostly on the ultraviolet, because there is nothing much happening on the ultraviolet radiation on the Earth. They mostly work with the visible radiation or the infrared radiation. Infrared radiation means you can see in the night time also. You don't have to bother about the sunlight. Then microwave. So in the microwave are having the larger wavelength. So you can see in the presence of clouds also. And some of the microwaves are actually, you can see in the presence of heavy rainfall also. So even if it is raining very heavily, you can see the ground very clearly. So that is the advantage of these sensors. And that is how they have employed. And then there are two kinds of sensors: active and passive sensors. Active sensors means they have their own source of light and own source of radiation. So how a satellite sees a cloud in different bands. So this is how they look in the infrared, visible. So once you make a measurement in the visible, the cloud will look different. In the infrared, cloud looks very different. Microwave, it will give you very different other properties of that. So visible infrared give you the top part of the cloud, but microwave give you slightly total inside of the cloud, because it can penetrate the cloud. And that is why you can give you the entire rainfall structure. How much rainfall is there? From visible infrared, you can't see anything below a few millimeters or few centimeters or maybe few meters. But here it will give you the entire depth of the atmosphere. So that is the advantage. And nowadays, current generation satellites which are operating in the visible infrared, they are very huge satellites actually. You can't imagine, they are like a truck actually. They're very big, and they have many instruments, and they measure Earth's magnetic fields also. They measure a lot of solar weather. They measure infrared. They measure lightnings also. So this is basically an example from the USA, where the fifth generation satellites, right? Current generation satellites, they have, and India is also acquiring such satellites in 2025 or maybe beyond that. But they are the most sophisticated geostationary satellites currently, which are operated by advanced countries like Japan and India, Japan and America, etc. So they have many large number of sensors. So these are the different array of different geostationary satellites. The GOES East, GOES West. India also has the INSAT 3D satellites, INSAT series of satellites, the Himawari. Like all these satellites are there, polar orbiting satellites, etc. So they give you different kind of measurements about the weather. And so INSAT India has a complete history and complete hierarchy, very rich heritage of the geostationary and the polar satellites. So that is the Oceansat and Saral and Megatropic. So many rich. It has contributed a lot to the world's global research. For example, India's CatSat satellite has provided data when there was no scatterometer satellite. So I'll come to the scatterometer, and there's a space debris. Basically, we have to bother about this also. So I'm not covering that because otherwise I'll spill from my. INSAT 3D is one India's operational satellite. So it works in different channels. What are channels? Channels are like filters. Just you use the filters in the camera, so you can give a different kind of. You can see certain things more clearly, and certain things you can block. So if you don't want to see some parts, you can use a certain kind of filter. And actually nowadays a lot of softwares apply these kind of filters on the digital image, and you can make that image look in a different way. So it is a digital filter, but in the camera, satellite camera, they are actual filters which are made of the glass or made of the different other materials, which filter that beam into the different parts, and then they give you this thing on a different things. And ultimately, they also can provide the vertical structure of the atmosphere using these filters. So this is the power of the multispectral imaging. What we see. For a human, this flower looks like this, like yellow color flower. But for a honeybee, for this honeybee, this flower looks like this. Actually, the central part of that looks different to the honeybee, because honeybee can extract those wavelengths which we cannot extract, which we cannot see. So based on that, it can find out just by its eyes. It can find out whether there is some nectar in that or not, or it is a completely dry. So that is why its efforts are basically optimized. So that is why the God has given that honeybee a vision to look in a different wavelengths. The same principle we apply for the satellite imaging, satellite sensors, and we use different bands. So this is the same cloud in visible channel, the same cloud in the shortwave infrared channel, same cloud in the microwave channel, same cloud in the thermal infrared. So you can see that they look very different, and they give very different information about that. For example, visible and infrared. Visible gives you how much water is there inside the cloud, and while the sphere gives you how much ice is present into the cloud. And when the presence of ice will give you when this cloud is going to rain, and whether it has rained or it will not going to rain. So it gives you a lot of information about the nowcasting. What is going to happen in next 15-20 minutes, or next half an hour, whether this cloud is going to rain or not. So those kind of lot of inferences can be drawn based upon the multi-channel images. Similarly, it can give you a lot of information about the hurricane cyclone stage, whether the cyclone is becoming more stronger, or how much is the intensity of the tropical cyclone. Because when there is a cyclone, there is nobody there to measure its winds. Still, these winds are measured, and you get reported in the news that this hurricane is very powerful and there is extremely category 3, category 4, and become a super cyclone. Who tells you that? There is no instrument. There is no wind measuring instrument there. So this is all is inferred based upon the infrared images, and there are certain rules that if the hurricane looks like that, if cyclone looks like that, then it is intensity. And nowadays there are automatic techniques. So there is an automatic program. There is a computer program which analyzes these pictures, and then it tells you that what is the surface wind speed of those cyclones. It is a very, very innovative method that was developed in 1970s. It is really unbelievable, and that method is still working. Can you believe it? It is working for last 50 years. So that was such an innovative technique at that time. It is not still replaced. Similarly, they can give you the wind, atmospheric winds, by the motion of the clouds. So there are a lot of products which are generated from the INSAT 3D, like sea surface temperature, outgoing long-range radiations, precipitation, rainfall, fog, snow. All these things are given by INSAT 3D continuously every 15 minutes. So this gives you a continuous monitoring at the same place, and then it is very, very useful. If there is a lot of rainfall, some big massive flooding is going to come, it can give you warning many years in advance that some flooding events is going to happen by the motion of those clouds. Similarly, you can even understand the intensity of the cyclone. Same things are in the ocean. Actually, we require these kind of measurements at a different frequency and different resolution. So for this, in fact, the resolution is 1 kilometer and 4 kilometer respectively. For visible, it is 1 kilometer. SWIR, it is 1 kilometer, and infrared other channels are 4 kilometers. So it is the resolution is 4 kilometer. You cannot resolve anything less than 4 kilometers in size. So, but in the ocean, you have to see the things in much more detail. For example, you want to know fisheries zone, etc., and you are working on the optical wavelength, where you can afford to have a very high resolution. So in the one very important monitor, that one important sensor is called the ocean color monitor sensors. And there are many countries have this ocean color sensor, but India has OceanSat 1, OceanSat 2, OceanSat 3. That is called the ocean color monitor. They have 8 channels. They have different visible bands, which can tell you a lot of things about the ocean. Basically, how much is the chlorophyll in that? What is the sedimentation inside the sedimentation? How much is the dirt inside the water? What is the dispersion of the pollutants? How much pollutants are being dumped into the ocean and how they are dispersing? Then you can also detect the oil slicks from that. Response of the oceanic biota means how much is the ocean biomass is changing with respect to that. Harmful algal blooms you can detect. Ocean hypoxia you can detect from that. So it is there high resolution, like 360 meters. 360 meters is quite high resolution compared to what we see from INSAT 3D, because these are from the polar orbits. As I told you that geostationary as 36,000 kilometers, it is at 800 kilometers. So resolution can change because you are very near to the Earth. Like this is the thermal image of the city. This is the infrared camera, and infrared camera at very high resolution operated from the polar orbits like Landsat and MODIS. This can give you the thermal structure, which of the parts of the city are very hot. So you can see the raw red and yellow area, they are the hot areas. And it gives you a lot of insight into how much is the energy requirement of those parts of the city. For example, when there is a lot of heating is going on, so which parts are more vulnerable to the heat waves. So those kind of information. And there is an Indo-French Trishna mission will be there in 2025, which will give you this kind of observation at 50-meter resolution. Now, what is required actually? We require a very large aperture size for making a. For example, if the distance is same, for example, if everything is in the polar orbit, forget about geostationary orbit. Even in the polar orbit, what do you require? Actually, you require a very large aperture size to capture the images in the high resolution. This is a very simple physics principle. The bigger the antenna you have, the bigger the lens you have, the better clarity you will have. So you can see that the binoculars you have or the telescopes, the bigger the telescope, the higher, the better quality is the image. That is very simple rule. So, for example, most of you people must be aware of the Hubble telescope, which has given a beautiful images of our universe. And now it has been replaced by the James Webb telescope, which has been launched last year. And you can see the difference of the size. This circular plate is basically the Hubble lens, Hubble mirror, which is around 7 to 8 feet. And this, this is how much it is, 6.8 meters. It's around 28 or something. Yeah, 21, 22 feet. This is how bigger it is compared to the human. You can see the human for the scale, and that is why there is a difference in the images of the Hubble telescope and by the JWST telescope. So the same kind of things we will require for the disaster monitoring, and one of the very high quality sensor is synthetic aperture radar. For the disaster management purpose, this is one sensor which can replace all other sensors. Let me tell you. So sorry. Anyway, there is a hyperlink to that. So synthetic aperture radar is basically, it synthesizes aperture, and it synthesizes the aperture basically to get the very high resolution. You should have a very large antenna, but actually it requires a very innovative technique. Is that as long as this point remains in the field of view of this satellite, this particular camera, it can keep on collecting these measurements, and ultimately it combines those phases and can produce a very high resolution image. So the advantage of the SAR image is that it can provide very high resolution image. It works day and night, and not only that it works day and night, it works under the cloudy conditions also. And it not only works cloudy conditions, it works under the rainy conditions also. So that is the biggest advantage. It is the mother of all the sensors for the disaster management. So this is the sensor, but the problem is that it is the narrow swath. It has a narrow swath. Suppose you want to work at a 3 meter resolution, it gives you 3 meter resolution, 1 meter resolution images. unparalleled, unmatched resolution it can provide. So, but the problem is that as you go in the swath becomes, as your resolution grows, your swath becomes narrow, and its processing is quite complex because you have to collect all the phases and all these things. So it is not just a picture. So you have to mathematically process all those images and then produce a picture on that. But anyway, you don't have to bother because you will ultimately get a picture from that, so which you can utilize. And the data size is extremely voluminous for the data. Ultimate picture is very small size, but the data that it collects to produce that picture is very huge. So that is the disadvantage. So there are some examples of the synthetic aperture, like the RISAT-2. They provide the resolution of 3 meters, and this RISAT-2, which is basically the defense applications, it provides the resolution of 30 centimeters, which is this is unimaginable resolution for any satellite. So this is the technology that enables you to do that, and some of the application of that, it can provide this kind of pictures of the DEM, the elevation of the map, and there are many applications of that. For example, the flood mapping. These blue regions, this is near Tamil Nadu region or Tamil Nadu Andhra coast, and these all blue colors are there where there is a massive flooding is happening. So if you have to monitor and if you have to measure this flooding by the manual area and by sending some people there, you will take many years to do this. While the one satellite picture can give you all the flooding area and at a very high resolution. The same thing in the flooding example. Oil slick detection. You can detect oil slicks very clearly from the SAR images, and you can really take the measurements from that. Then this is again the example of the ship detection and the oil detection. You can see all the dark area, which is all under the oil slicks. You can see, there is interferometric SAR, and there was a earthquake in Turkey. Not now. This image is not for the recent earthquake. It is in 1995. Also, there was an earthquake. And if you compare the two images, you can collect those phases, and you can collect the interferogram. And this interferogram, it tells you where the land dislocation has taken place because of the earthquake, where the earth is shifting. Like in the Joshima, Texas, some people are saying that Joshima also the land shifting is taking place. All this kind of information, the ground-based measurement cannot handle this kind of vast scale demands of the ground dislocations. So this is possible by the phase information of the radar. Like similarly, the damages, structural damages. You can see this. There was a big storm which uprooted a lot of trees. Can you see this area where you can see this white color things? You can see this white areas. This is the areas which are affected by the forest, and you can see this area. This is the intact forest where the storm has not created damage. This is the damage, this is the undamaged, and this is the information. If anybody tries to get it manually, it will take a huge amount of effort and huge amount of time. But the synthetic aperture radar, just by its technique of the observation, it can create this kind of pictures. Similarly, this is the damage created by the wildfire. This can you see this kind of how much damage has been created by the wildfire, or not only damage created by the wildfire, but by the storms. Like sometimes the cyclones come and they damage huge property. In the United States, it is very easy to find out. Next day itself, you will find out how much damage has been created, because everybody will go to the insurance company, and that insurance data will give you that how much damage has been created. So it will, within 1 week, that how much damage has been created. But India, not everybody insures his house, or not everybody insures his property. So it is very difficult to find out in India and many other countries that how much actual damage has taken place. So the satellite synthetic aperture radar technology is the best thing for measuring this kind of damages. Then similarly, you can see the very high resolution pictures of the tropical cyclones. In 2 minutes time, I'm going to wind up. So there are many other observations, like the vertical profiles from the microwave. The microwave has one advantage, that it can penetrate clouds, and you can get a lot of other observations which is not possible to get. Sea level rise, sea level measurements is also given by the microwave. Microwave is basically a radar which sends a pulse, and then there is a return pulse, and depending upon the shape of the return pulse, they can find out how much is the shape and how much is the altitude of the satellite. And if you collect these observations for the many years, then you can find out where and how the sea level is changing. So that is there are many missions, like Ultica mission was there, which was the Indo-French mission basically, and there are so many other parameters which can be measured from satellites. There are some other new measurements are coming from satellite, which are a very unusual application of the GPS. So everybody of you are using GPS. So whenever some Amazon guy comes to delivery, or some Zomato or some Swiggy person comes to you, they are using this technology for GPS for mapping purposes. But you know, this GPS signal, when they are getting, it is affected by the temperature and atmospheric vertical moisture profile of the atmosphere. So they get this signal slightly delayed. So your delivery boy gets the signal, instead of in 1 second, it gets in 1.002 seconds. So for your delivery boy, it doesn't matter whether it is 1 second or 1.2 seconds. But for atmospheric science, it has a lot of meaning actually, because based on that delay and what path it is taking, you can tell a lot of things about the atmospheric structure. So what is the structure? Vertical atmospheric structure, vertical humidity structures, which gives you very precise information. And you know, when you ingest this data into the models, the model performance improves a lot actually. And that is why a lot of satellite, a lot of people nowadays are interested in this technology. They're putting more and more GPS satellites into the orbit, and they are trying this information for knowing about, you know, these are the paths of this beam when there is no, so there is a bending, it bends depending upon the temperature structure. So it means by computing this bending, you can find out the temperature structure of the atmosphere, and it gives you a lot of information about the storms, about the floods, what is going to happen, whether the heat waves are, where they are traveling, and all these things. So ultimately it helps the weather forecasting. And there are many other, like the GPS spectrometry, which I'm not going to cover there, maybe for the advanced purpose. So that with that, this is I have come to